Greetings everyone! Today we are going to continue exploring solving logarithms. You will need a calculator, so make sure you have that readily available and you'll want to take notes on these examples. Remember from our previous video that there are two types of log equations. There's ones with logs on both sides of the equation, and there are ones with logs on one side of the equation. Let's take a look at an example where there's logs on both sides. You want to use the property of equality, which we've used for several years in algebra. We want to make things equal on each side. Make note in this example that if each side has one log that is exactly the same, then to solve, we actually don't need that log. So we can write down the expression from each side. Now again, you have to have only one log on each side, and it needs to have the same base in order for this to work. From here, then there's nothing new. We just want to get x by itself. So I'm going to subtract 1x from both sides, add 7 to both sides, and divide by 3. We can also check our answer very easily. If I fill in 4 for every x value, and I simplify, it should be very clear that I'm correct. So especially on a test, this is worth checking out. So I end up with log base 5 of 9 and log base 5 of 9, which is a true statement. So I know that my answer is right. Here's an example where a log is on one side. First thing is take care of any of the easy algebra moves, the ones that you learned years ago. For example, move that 7 over to the other side. You want to isolate that log. Now from here, there's no other moves that I can make from previous algebra years, but I can use my log and transform it into an exponential. So the base becomes the base, the answer becomes the exponent, what's remaining becomes the answer. From here, now it's easy to break that down and I end up with 1 over 1,000. Negative kicks it to the bottom, 10 to the third is 1,000. Again, you can check your answer on this one. Because it's log base 10, I can actually type this one directly into my calculator and see if I end up at 4. Just be careful with parentheses on some calculators because of that fraction right there. Again, start this equation off by using the easy algebra rules first. I'm going to subtract a -3, which changes to adding. We want to isolate that log, so let's take care of that 2 because it's on the outside. Now from here, I need to use my new rules that I have, and I need to convert this to base e. ln becomes e, the answer becomes the exponent, what's remaining becomes the answer. E to the 4th, I can type that into my calculator and get an approximate answer of 54.598. Depending on the directions, sometimes you'll leave it as e to the 4th, and sometimes you'll write it as a decimal. You can also check this answer. Just know that if you are using the rounded decimal, when you plug it into ln, you won't get exactly 5, but you should have very, very close to 5. In this example, I need to isolate that log. I can't do anything with the x plus 6 because the log is affecting all of it. Therefore, I actually need to convert this right away to exponential form. The base becomes the base, the answer becomes the exponent, what's remaining becomes your answer. Once you convert those, it should be very easy to solve those. If it's not, then take a look at your transformation and if it was correct. 2 to the 5th is on my chart. It gives me 32. I'm going to add 6 to both sides, and I end up with x equals 38. I can check my answer. Log base 2, 38 minus 6 would give me 32. If I plug that in my calculator, I can use change of base formula, and I should get 5. Let's take a look at this last example. Pay very close attention to the fact that there are only logs on the left side. The fact that there are multiple logs on the left side also shows me that I need only one log on the left side. This plus sign tells me that I'm going to have to use my condensing rules. Instead of addition, my log values are going to become multiplied. Bring down that right side. Second, let's take care of that multiplication. Let's do distribution so that we don't have any parentheses. Now all of this is being affected by the log. There's only one log, so now I can transform it into exponential form. If I do that, my base becomes my base, my answer becomes my exponent, what's remaining becomes my answer. Now if I look, this almost looks like a trinomial. I can make it a trinomial by subtracting this 64 from both sides. So I end up with 0 equals x squared plus 12x minus 64. It's a trinomial, which means we need to try to factor. If it doesn't factor, you will have to do quadratic formula. But always try AC first to see if it works. A times C is negative 64, and my middle term is 12. Take a moment to pause the video and practice this factoring process. My factors for negative 64 are going to be negative 4 and 16. Remember to do the grouping steps, but if I break it down all the way, I end up with a value of x minus 4 and x plus 16. So in the end, I have solutions of 4 and negative 16. Other than those first two steps, everything else is just a refresher of factoring. So for that second part, if you have any struggles, you'll want to look back on your notes of factoring. Now we also have to check our solutions. If I plug in, let's start with the 4, log base 4 of 4 plus log base 4 of 16, I can follow through with the same simplifying steps, or I can do change of base formula and plug in those decimals. But in this case, no matter what, I do end up with 3 equals 3. So I know that 4 is a good solution. Let's take a look at negative 16. If I plug in negative 16, I end up with a negative 16 on the left and a negative 4 on the right, and still equal to 3. Now, if you try to do change of base formula here, we can't. I can't have a negative log value. So because I can't have negative logs, negative 16 is not a solution. So we're only left with x equals 4. So check your answers, and if you have negatives, feel free to try it out just to confirm so you know in your calculator what that means. Log of negative 16 divided by a log of 4. Depending on your calculator, you might see something like an error. Let me know if you are concerned about your calculator and how it's creating that. Okay, so take your time on these. If you only have one log, transform it. The rest might be factoring or solving for x. Check your answers, and negative logs won't work. In preparation for next class, You're going to want to have your Solving Day 1 worksheet completed. We're going to continue working on these solving problems. I know it seems repetitive, but these can end up being some pretty tough ones. So we're going to continue our solving practice in class. Make sure you check your gradebook to see what else you're missing. And take some time to catch up. We only have a few days of math class left, and it looks like our test for this unit will be the beginning of next week. We'll see you next time.